Hello, everyone. Good morning and welcome to Live at the Waterhole. We're first up. We're in the Madikwe Game Reserve of the Northwest Province of South Africa at Jamala. And well, it is an action-packed start. My name is Ralph Kirsten, and what does the bush hold in store for us today? Well, you'll have to sit back, relax, and watch the animals coming down to the waterhole. Looks like it's going to be a scorcher, and it's going to drive a lot of the animals down to come and cool off and have a drink. And as per usual, please don't forget that this is a live and interactive experience, so we'd love for you to jump on board with us and send us through your questions and your comments. You can do that by going on the WildEarth website and registering. You can also join the conversation on X, formerly known as Twitter, and you can use the hashtag WildEarth, also on the YouTube live chat. We'd love to hear from you. Seems like we're going to be hearing from the elephants today once more. I'm pretty sure that it's going to be generally hot across the different locations, and so that will mean that the elephants will come through. Nice vocalization there from the zebra. Also coming in for a drink. Seems pretty parched today. Nice and hot. But that always bodes well for us, sitting at the different water holes, because the animals then do like to come down for a drink. And some, like these little young elephants, like to play as well. A couple of blue wildebeest there as well. Also known as the brindled gnu. We've had lots of activity from the elephants over the last few days. It's been nice and hot, so this is what we can expect going through the rest of the day. And speaking of the heat, I think it's time to go and have a look what the weather's going to be like across all the different locations. So lots of heat all round. I think it's only at Old Donyo in Kenya, East Africa, a little bit of rain, and that's obviously making it a bit cooler there. But I'm sure the humidity will be very high. But, well, there's no rain here. Open skies and lovely and hot. Ah, Lucy, so you're also here for your elephant therapy. I think there's lots of people that have been enjoying the elephants coming down for a drink. As you see that one young bull just chasing the zebra off in the background. There's been lots and lots of antics, lots of playing and communicating, trumpeting, rumbling, splashing around in the mud, all to be expected once more today. Now the zebra getting chased off on this side as well. I think the elephants quite enjoy it, especially the young bulls chasing the animals around. They're easy targets, I think. So the elephants have really been enjoying this waterhole in particular. Has been full up with ellies. And it does sort of give a bit of bad news to the other animals because they generally get chased around like this. And so sometimes need to wait until the elephants are done. So, leopard lover, it is in fact correct. This is the best place to be in summer when it's nice and hot. The animals all coming down for a drink. And yeah, we have seen a couple of the different, not so much here at the other locations. We've seen some of the warthogs also wallowing, where it's a little bit quieter. It's a bit difficult for them now to squeeze in a gap here somewhere without getting chased off by the elephants. So they seem to be dominating this waterhole and really have been making it into a complete mud party. Over on this side is where they come to drink. There's the fresh water just coming out. So the rest of the waterhole now turned a turbid, muddy color from all the rolling around and playing. So I think it won't taste very nice. So that's why they're drinking over here. So the zebra will have to pretty much take what they can get, but you can see that one is trying to drink, but I think it's not tasting very nice. So it's trying different spots, but it's not really to its liking. But I don't think they're intelligent enough, or they might be, to know where this fresh water is coming out, but it's dominated by the elephants nonetheless. So even if they wanted to, they won't be able to for a while, I think. Let's see if that individual is going to have a bit of a scratch on that rock in the water. Looks like it's making inroads for that. Going to get a good old belly scratch. So, Cherry, yeah, good question around the successfulness of the social structures of elephants. I think they're one of the more successful. But if we have to look at the most successful social organisms, we'll probably have to go to the insects and the likes of termites, ants, and most prominently bees. I think they're probably the most successful in terms of their social structure and the communication and the whole social network. And so much so that we studied them a lot with wildlife management as the example for the organisms that work together, them being the best at it. And I think then ants and termites. And yes, the elephants are very good in terms of the mammals. But I think most of it comes down to their intelligence and their empathy towards each other. So I would say that they're one of the more successful of the mammals in terms of their social structure in particular. And when we refer to the insects and the bees, I mean, they've got a total caste system and everybody does their job as expected, from the workers to the soldiers to the queen, and them all looking after her and all working towards the same goal.
Africam brings the wild to you. Watch the big 5 at our Waterhole cameras. Indulge your passion for birding with the black eagles on the Black Eagle camera, flamingos at Camphor's Dam, and penguins at Stony Point. Listen to the soothing sounds of Lisbon Falls, or witness animals up close at Cat Eye Pan. Imagine you're at the hide at Aldonio Lodge, gazing at elephants with the majestic Mount Kilimanjaro as your backdrop. Join us at Africam for an extraordinary wildlife adventure.
So, going back to the question on the most successful animals' social structure, I mean, all these animals are busy and are gregarious because they're all grouping together. The elephants, the zebra, as well as the blue wildebeest, they're not so many here now. But I mean, it's difficult to understand or to measure who would be or who would have the most successful social structure with the animals here. I think we'd have to look at the different hierarchies within the group. I mean, with elephants, we talk of the breeding herds with the matriarchy, so a leading female with her kind of generals in the females, the younger ones. and the ones that help her to look after the babies. And then obviously the big bulls, where you would have a kind of dominant bull being a patriarchy within the different areas, getting mating rights over the females. So, I mean, because of their intelligence, they have all sorts of moods, etc., and their social life is still depends on that hierarchy, though, because they follow their leader, especially the breeding herds. So I would say that is a very good social structure that they have. But how do we judge its successfulness? Well, they're all there and they seem to be quite calm, most of the time. But it's the same with the zebra. There's so many of them. And they obviously form harems with dominant stallions, but they'll keep on trying to steal other females. So their groups are, can be quite similar to the breeding herds of elephants in size, sometimes just 8 to 15 or so of them, as we now see a small part of a herd of buffalo. Maybe there's more coming. It might be part of a bigger herd of buffalo, all coming to maybe try and compete for this waterhole with these elephants. Now, they're also sort of very successful in their gregariousness or their social structure. They've got a number of dominant females as well as bulls that will lead the herd. And you have these kind of pathfinders that go ahead of the herd, leading them. But if there's any danger presented from predators, they'll very quickly form into formation with the females and the youngsters on the inside, and these big bulls corralling them and keeping them safe. So I think very successful as well. If we have to look at the primates, baboons and monkeys, also the baboons having led by a gang of males, and so it's very different, but also very successful. There's a real hierarchy within the primates, monkeys as well. Not quite as harsh as the baboons, but it does lead for them. They're more arboreal than the baboons are, and smaller, and so have a slightly different social structure, but quite similar result. So I think with all the animals here, very successful in their social being, but it's not necessary to be social to be successful. If you look at the likes of leopard, which is one of the most widespread big cats around on the planet, they're solitary mainly, and can live even in urban environments, and all on their own. So not truly necessary to be social to be successful. So we could say then leopards would be sort of one of the more successful, and they just do things all on their own. Or do we compare with elephants that do, the breeding herds help each other out all the time, all similar to the bees, trying to work towards one goal. But the bulls sort of throw a bit of a spanner in the works. They're not really necessarily concerned with bringing up of the young or anything like that. All they want to do is mate with the females, and then off they go. So not concerned with family life, but it's still a successful tactic or method or strategy, as with all the other animals that are present here. I think in any kind of social structure, there needs to be a clear-cut hierarchy, and that is what's maintained in the wild, across species and within the same species. So you can see here that the dominance of the waterhole stands with the elephants, but the buffalo is slowly making their way through now, growing in numbers. And it just makes for interesting viewing. Buffalo being one of the true wallowers as well. They love the mud, and so I'm sure they'll be quite pleased that the elephants have mixed it up nicely here, making it lovely for wallowing. rhinos, also true wallowers, as well as the warthogs. That individual still getting a scratch on that rock. Seems like the perfect height. And just shooing the buffalo off there, throwing a bit of water at them. So you can also understand the hotter it is, the drier it is, the more the animals want to come down to the water and want to get stuck in, want to cool off and drink. But it does land up with concentrations of animals like this. The chances for conflict rise. And that can be within the same species, where there's different territorial animals that come down at the same time, as well as between other species as well. And so the elephants chasing the buffalo away and all the rest. But now the zebra having to wait off in the background before these buffalo are finished. But you can get conflict between these different animals as well. So, Linda from California, nice to have you on board with us. And there is so much going on here. You almost don't know where to look. I have to agree with you.
Cheetahs are one of nature's prolific gems. Jump on safari as we celebrate International Cheetah Day. Alongside an interview with the woman who established International Cheetah Day, Dr. Laurie Marker, we will search for cheetahs live across Africa and share some of our best cheetah sightings from over the years. Join us for our cheetah chase. WildEarth, keeping up with the fastest land mammal on Earth.
That elephant bull just having fun with the buffalo now, chasing them backwards and forwards. Shame, and all they want to do is come in and wallow. Doesn't look like they're going to get much chance. So there's a tiny little baby with that one elephant that's just come in on the opposite bank. That female's now spraying herself. Just underneath there's a tiny little one. As the buffalo are getting harassed now, this youngster here closer to us. That looks like an old buffalo bull, not too keen to be chased off. So Jess, yeah, that's correct. Those pathfinders, they sort of, up on the upper rungs of the hierarchy within the buffalo herd. So they're the ones that normally lead and decide which way the herd is going to move. But if there's any sort of danger presents itself, immediately the bulls will come to the fore, and then they form like this wall. In the front, keeping the females and the babies on the inside of that. So with pathfinders in mind, I found a nice little blog on the Londolozi website, and it's written by Chris Taylor, and he says that when one delves deeper into the animal kingdom, and more specifically their social structures, we realize more than ever that humans are really not that far removed from the natural world, and that certain concepts that we have taken centuries to conceptualize actually already exist all around us. There are countless examples of this, but let's take a closer look into the lives of African or Cape buffalo. And one of the more underrated sightings is watching a large herd of buffalo approach and wade into a waterhole, just like we're watching here. For seasoned safari goers, the buffalo is often considered the underwhelming item of the big five, but there's a lot more to them than what first meets the eye. If we take a look at a large breeding herd, which can easily number over 1,000 individuals, this one here being a lot smaller than that. In some areas, we are met on the surface by a mass of lumbering bodies and a constant bellow of deep grunts and groans. They're getting drowned out a bit here by the elephants, but nonetheless, Beyond this, what you'll find is a fascinating and intricately structured herd system that closely resembles that of our supposedly democratic human society. Associating in a herd benefits countless species in the wild and generally arises through their efforts to increase their security and share resources. As is the case with humans, though, whenever there are a large number of individuals coexisting, systems need to be put in place that lend themselves to the smooth running of the herd or society and allow the animals or people to coordinate their day-to-day activities and avoid unnecessary conflicts as much as possible. Just as in our human societies, systems can fail, conflicts will arise, and there will be losers. But watching individual buffalo within a herd, we can quite easily observe them as they establish and reinforce their social status with subtle signals of body language, vocalizations, and even odor, all of which we as humans can also be seen responding to amongst each other, albeit on a more subconscious level. But furthermore, ecologist Herbert Prince, who spent years observing buffalo behavior, formulated a theory that the large herds of buffalo, in fact, have a rudimentary voting system to determine the direction they move in. He noticed that towards the end of the day, while the buffalo still lay and rest, the mature females of any social rank would routinely stand up, shuffle about, and sit down again, now with their heads held high. This will usually happen within an hour before the herd begins to move. After recording the direction that each female faced on every particular afternoon, he calculated the average direction they faced for each day. When it came time for the herd to start moving, the herd would rise and move off in the direction that the majority of the females were facing. This ultimately showed that the mature females of a buffalo herd were acting as the Pathfinder Committee and would vote as to the direction they thought the best pastures and water would be. A fair amount goes into this decision making as these large herds feed in cyclical routes through a home range area, doing their best to avoid other buffalo herds. They need to consider rainfall, topography, vegetation types, habitat, availability of water, and even soil types, all while avoiding areas that have been recently grazed, be it by another herd or themselves. This requires local knowledge, which would have been learnt by these pathfinder females as they grew up in the same herd, learning from their elders. Their knowledge and guidance then benefits the herd as a whole, particularly the younger individuals who are inexperienced in finding suitable grazing and water. So while some of the benefits of herding are fairly obvious, such as safety, others may require a bit more observation to fully appreciate. The next time you find yourself sitting with a large herd, take a bit of time to watch the restless females and hang around to see who wins the vote on that day. So, Carl, they can drink this muddy water. I doubt it will make them sick. It generally wouldn't. It just probably won't taste very nice, that's all. But they'll probably collect that sort of sand and mud particles in their digestive tract and will just be passed through. So I don't think health-wise it's an issue. I just don't think that it would taste very nice. So, Ingrid, I do believe that the origins of tuberculosis may have come from cattle. I'll dig into that and just make sure on the facts, but I'm pretty sure that it has been passed and brought through with the livestock and cattle in particular. So, but that's a nice question for us to delve a little bit deeper. So, hang five. I'll see what I can find.
It's a festive Wilderland. Come along as we go in search for various festive wild animals for the 12 days of Christmas. From honking geese and roaring lions to hooting owls and leaping leopards. Tune in on your nearest device and join the festive fun. Watch the live show from the 14th to the 25th of December. Don't miss out. Embrace the festive season with WildEarth.
So, on the subject of tuberculosis, and specifically in buffalo, but also in general, and the origins thereof, and I found a little bit of nice write up from the Ingwelala website. And they say that tuberculosis, TB, is a disease affecting cattle and a variety of wildlife worldwide. It's caused by a bacteria, Mycobacterium bovis, that gains access to the body via the respiratory or alimentary tracts or through the skin. Depending on the climate, the bacteria can survive for days to weeks in the environment. The first reported cases of TB in wildlife in South Africa was in 1928, when the disease was recorded in Kudu and Komondake. An isolated case of TB in an impala in the Crocodile Bridge region of the Kruger National Park was recorded in 1967. TB was most likely introduced into the Kruger National Park on the southern boundary following intermingling of buffalo and infected cattle in the 1960s or 1980s, but remained undetected until 1990 when it was diagnosed in a two-year-old buffalo bull. Currently, more than 90% of the buffalo herds in the south of Kruger have TB, Buffalo infect each other by the inhalation of infected droplets produced by coughing or sneezing. When infection progresses to disease, buffalo gradually become emaciated and anorexic. In advanced cases, coughing and breathing with difficulty is seen. In Africa, buffalo are maintenance hosts. They carry the disease, and it's suggested that lions and kudu may be additional maintenance hosts. TB has been recorded in 13 species by 2006, so probably quite a few more in the Kruger National Park. Infection is due to incidental spillover from infected buffalo to susceptible species. Species in which tuberculosis has been recorded in the Kruger National Park are buffalo, lion, kudu, eland, warthog, bush pig, large spotted genet, leopard, spotted hyena, cheetah, baboon, impala, and honey badgers. Buffalo carcasses are the most likely sources of infection in carnivores, particularly lions, which are infected via the gut when feeding on infected carcasses. In the Kruger National Park, buffalo constitute about 4% of lions' total food, although this figure may be higher in the Timbavati and in different other areas. Once infected, a lion can shed the virus in aerosols and infect other members in the pride due to their highly social nature. Infected lions may show signs of progressive weight loss, poor healing skin wounds, joint swellings, muscle loss, and eye lesions. TB in lions contributes to lower lion survival and breeding success. Increased cub death due to foster territorial male turnover is occurring. Abnormal sex ratios have been observed, and some male and female prides have been evicted from their territories. In the Kruger National Park and surrounding areas, a progressive northward spread of TB is occurring. In areas with high buffalo herd TB prevalence, up to 90% of the lions in the corresponding areas are infected. Vaccination is the control measure of choice, but an effective wildlife vaccine does not currently exist. In the Kruger National Park and surrounding private reserves, it's hoped that buffalo and lions will adapt to TB through natural selection of more resistant individuals, although this may take several generations. And this is also one of the reasons why you do sort of have these veterinary fences and borders, both in Namibia and in Botswana, because they don't want the movement of wildlife between. It's normally sort of the north and the south, and then mixing, especially foot and mouth as well as TB, are the two diseases that they want to stop or try at least slow down the movements. And as well, when you move from South Africa to Namibia, as well as South Africa into Botswana, you may not take any meat products, and that includes eggs, cheese, any animal products are not to be moved between the borders. And then in Namibia, there's a veterinary fence that goes from Etosha right through Palmwag, and then you can't go through there. And in Botswana, they have many veterinary gates, and they try to stop the spread of this disease. In Botswana, you often have to stop and you get out, and you have to walk on these mats, and you have to drive your vehicle through these dips, and that's also for flies, but they also check for meat, and to just try and stop all this movement of disease. So, leopard lover, I haven't been able to have a look at Pilanesberg to be able to tell you firsthand experience or knowledge that Pilanesberg is recovering. However, all I can say is that fire, it was terrible, and it caused a lot of damage. But if I had to choose a time to have a fire, it would have been then, because it just before the onset of rains and the period that we would expect rains. So the potential for recovery is good, and there has been some good rain around. So I would expect that, it cannot even be a blessing sometimes, because even though the damage that it caused to the buildings and infrastructure on a natural front, these burns can often, especially when it's timed right, it can really do a lot for succession and releasing of nitrogen back into the soil. And sometimes you can actually have a more positive outcome after the fire and the recovery has taken place. So, yeah, terrible, but I'm pretty sure it's already underway, the recovery, and we'll probably see quite a bit of greenery coming through there with the rain that has come after the fire was that ripped through there. So, Lenny, you're very welcome on the TB information. I do want to follow that up. I'm just researching some nice information on disease-free buffalo, because we'll get into it. And there are isolated pockets of populations of buffalo that are TB resistant. And we have quite a bit of that. I don't know if there is in KwaZulu-Natal. They're definitely in the Eastern Cape. And so they had a lot of breeding projects, and then they want to try and move those buffalo into the areas where this TB is very prevalent, and try and breed this gene of the buffalo that are resistant to it into the local population. So I'm going to try and get some information on that, but it's also quite similar to, lions. They get something called FIDS, which is feline immunodeficiency syndrome. So like we get AIDS, acquired immunodeficiency syndrome, cats get FIDS, and it can be quite prevalent in them. But in Etosha, those lions are FIDS immune or resistant, and so they don't get it. So those Etosha lions are also sought after to breed into other populations where this FIDS is very prevalent. So that is also a technique or strategy, conservation strategy, in terms of trying to combat these different diseases that they have. However, there's always the question: are you sort of changing the local dynamics of the species there by bringing in ones from alternative areas? So there could be that argument, but obviously with the prevalence of a disease and that being one of the solutions, obviously.
Welcome to Destination Safaris, WildEarth's travel show.
Beautiful Hills Neck Safari Camp is an intimate family-run lodge nestled here on the banks of the Bushmans River. This week we'll explore this intimate camp engulfed in stunning views of Amakhala Private Game Reserve.
So, continuing on a little bit of the conversation of tuberculosis and specifically now moving towards disease-free buffalo. And I've found a lovely article on Farmers Weekly, but this is mainly obviously centered around game farming, but it's still very relevant with the species as a whole, and has good information on the different types of buffalo. So they say that all buffalo in South Africa are of one species, but are defined by ecotype: Kruger, Addo, KwaZulu-Natal, Madikwe, and East African. These distinctions will diminish over time as breeders mix genetics to improve herds through hybrid vigor. Historically, buffalo in South Africa have been restricted to 4 ecotypically defined groups: Addo disease-free animals, Umfolozi Hlui corridor, and bovine tuberculosis positive animals. Kruger National Park infected animals, and disease-free stock from foreign zoos. Originally, only Addo buffalo and stock from foreign zoos were available as disease-free stock. Of the first 3 groups, Kruger National Park buffalo are the most genetically diverse, as proved by Professor Eric Harley from the University of Cape Town. However, buffalo from foreign zoos were excluded from his genetic variance study. If Kruger National Park buffalo were to be made available to buffalo farmers in the disease-free regions of South Africa, they had to be certified disease-free. But how? Breeding disease-free buffalo from disease-positive parent stock is a relatively recent breakthrough in Southern Africa. The pioneers worked with Dr. John Condi, a vet with the then Rhodesian Veterinary Department. His far-sighted approach laid the foundations for future projects, but he was 20 years ahead of his time. It wasn't until 1998 that Hunt Africa launched the first commercial project in South Africa to breed disease-free animals beyond the foot and mouth disease red line, using techniques developed by Dr. Condi and Dr. Roy Bengus of Skukuza. The success of this project has seen many other projects developing, all contributing to the spread of buffalo into areas where they have long been extinct. 2 buffalo ecotypes, disease-free Kruger National Park buffalo and disease-free KwaZulu-Natal buffalo, are available as a result of these projects. But why the controversy? KwaZulu-Natal and Addo buffalo originate from greatly reduced nucleus herds decimated by a combination of hunting, habitat destruction, and the rinderpest of the 1890s. Arguments rage about the real number of buffalo left in these nucleus herds. Professor Harley's research shows that the number was too small to prove loss of genetic diversity, which is conclusive in itself. Kruger National Park buffalo have wide genetic diversity, so why would current owners of KZN and Addo buffalo not all buy as many disease-free Kruger National Park bulls and cows as possible to improve their genetic lines? Professor Harley stated that substantial variability could be maintained in these populations by regular introduction of individuals from the Kruger National Park population. Kruger National Park buffalo have been available since 1999, yet many buffalo farmers have resisted the opportunity to improve their genetics, mainly due to the risk of disease. This is a stumbling block as few buyers understand the disease implications, and some breeders claim to be less risky than others. There's also a belief that Addo and KZN buffalo are less risky than disease-free Kruger National Park stock are, and that East African buffalo are the least risky of all. The East African market is an entirely separate and even less quantifiable model. Buffalo were exported to European zoos before 1960 and before Dr. Robert Hedger and Dr. Condi discovered that buffalo were carriers of foot and mouth disease. The exact origin of these animals and their genetic diversity is difficult to measure. East African animals have, to date, always sold at a premium on the perception that they have the widest horns and are scarcer. Their clean status has also contributed to their price premium. Quite simply, prices are driven by supply, demand, and perception. But, I think ultimately that just shows what I thought to be correct, in that areas where these disease-free buffalo do occur or naturally occurred the nucleus of those herds is very small, and so the genetic diversity is at risk if we just start breeding with them, which does put a bit of a spanner in the works, but I think could be part of the greater solution of trying to eradicate or at least keep under control the tuberculosis and foot and mouth disease. So, and also just a little bit on the disease dilemma. Buffalo are hosts to two African diseases, namely foot and mouth and corridor disease. Both can be determined by blood tests. Both have little or no effect on buffalo, but are dangerous to non-resistant ungulates, especially domestic livestock. Buffalo can also contract bovine tuberculosis and brucellosis, or contagious abortion, European diseases alien to Africa. Buffalo act as carriers and hosts and are affected by the diseases. These diseases are difficult to detect and can often be present undetected even in a herd, even if regular blood tests are done. Buffaloes from disease-free breeding projects are rigorously tested. They must pass a minimum of 4 negative tests in different stages of quarantine before being moved. These tests include a skin reaction test for BTB and blood tests for the other 3 diseases. The protocol is designed to make sure no animal reaches a clean area or stage 4 unless certified clean of all 4 diseases. There's some dispute over corridor disease transfer, an article in itself. Until Project Buffalo reach the 5th and final stage of testing, they remain a higher risk than animals born into disease-free herds. But many would agree that a 5th stage Kruger National Park Project Buffalo is as clean as any other. So, major problem being the carrier of these diseases and passing it on to livestock and cattle, and obviously that then has a real impact on the neighboring farms of all of these game reserves. So that's where the mix of domestic and wild animals really becomes a problem, and buffalo very quickly do and easily mingle in with cattle. So then it would knock on to the neighboring farmers and obviously have a huge impact there. Once the diseases are picked up in a herd, the whole herd needs to be quarantined and sometimes destroyed to stop the spread of it. And so it has a huge economic impact to the farmers of the region. And so this is the reason why there's so much control around it as well. So Jive Bunny, referring to S8, the male lion that seemingly died of as a result of TB. It definitely does bring that more than into light, and the understanding of this disease and how a lot of the animals are actually carrying it. But it takes for them to have a compromised immune system for it to start to show its head. And in the case of S8, it seems like that, being attacked by a buffalo, getting injured, having a slightly compromised immune system brought that to the fore. And as a result, he died of TB. So very interesting, but also interesting to note that, that it could also start to form part of the natural selection process, where the weak animals then are very quickly weeded out, and the strong genetics then obviously continue to go through. But trying to control this kind of disease that has been brought in through human activity, that's when we, us as humans, especially, in national parks and the management thereof, it is those cases when they can get involved, to try and assist the animals, because it's as a result of our activity in the first place. So that's where they do get involved sometimes, not always. It depends on the circumstances, but obviously first and foremost trying to limit the spread of the disease. And then if the animals do get it, they sometimes do help. But it's still in a sort of a research phase, because they're starting to believe that the animals, are slowly adapting to and living with this disease. And maybe it's just still in its infant phase of this evolutionary adaptation from the animals. And so you will have some animals dying from it, but who knows? Maybe eventually they will naturally become resistant to it. Because it's very difficult to stop. So the best would be for natural immunity to occur, because then that is the animals' bodies that have evolved that, but it can take a few generations. So hopefully that's the end game, is them actually being able to find their own natural immunity.
Get ready for a flurry of feathers and beaks. WildEarth is celebrating BirdLife South Africa's 39th Birding Big Day. Join our naturalists on drive as they compete to spot the most bird species across locations during Sunset Safari Live. Don't miss out on the fun. WildEarth, it's in your nature.
So the action just continues. Still lots of animals here, mainly dominated by the elephants, a couple of buffalo, and of course the zebra, just patiently waiting their turn. Dina, yeah, nice question around cancer and elephants. I'm pretty sure they can, and we've noticed some of this, but once again, I'm going to obviously refer to scientific journals and research and bring up all the cases or the instances where it has been found. So let's see. Right, so I found a nice article by the Cancer Research UK, and I think that's probably a good place to start. And they say, what can elephants teach us about cancer? They're bigger, stronger, and somehow still cuter than us, but elephants aren't show-offs. I don't know, sometimes they show off here quite a lot, but it's all in the name of fun. You have to look closely to understand just how amazing they are. Start doing that, and you might just learn something about yourself. Zoom all the way in, and you'll see that elephants and people are made of the same tiny building blocks or cells. The numbers are just a bit different. A single African elephant has about as many cells as 100 adult humans. With all these extra cells, elephants should be more prone to cancer, which begins when the DNA in cells mutates, causing them to grow and divide uncontrollably. Cancer science tells us that more cells means more chances for mutations, especially as living things get older. Elephants and humans have similar lifespans, but 70-year-old elephants are actually less likely to get cancer than a 70-year-old human. Much less likely, in fact. Cancer is extremely rare in elephants. A quarter of all human deaths in the UK are caused by cancer. Our stats on animals isn't exact, but one study suggests that for elephants, the number is more like 1 in 20. So what's going on? Why don't more elephants get cancer? Like us, elephants can recognize themselves in a mirror. They have dominant tusks, like we have, dominant herds, and where we wave or shake those hands to say hello, they twirl their trunks together in something a bit more like a hug. They can do long-distance communication. Elephants use the earth for a phone. Thumping out footsteps and calling with rumbles, other elephants can hear through the ground. But elephants don't do some of the riskier things people do. It's important to remember that lifestyle factors like smoking make cancer more common in humans than other animals. Still, that doesn't fully explain the difference in cancer rates. Elephants are so big that without special ways of preventing cancer, they probably wouldn't be able to exist at all. To be clear, though, elephants can get cancer. The surprising thing is that they aren't any more likely to get it than other animals. In general, the bigger an animal gets, the more its cancer risk increases. Dogs are a useful example. Large breed dogs have many more cells than small ones, and they're also more likely to develop cancer. But when you compare different species, size doesn't seem to matter. According to a study carried out at the San Diego Zoo, elephants have about the same cancer risk as striped grass mice, which are 100,000 times smaller. The fact a species' cancer risk doesn't increase with its size is called Peto's paradox, after Professor Sir Richard Peto, a researcher who first laid it out in the 1970s. If we can solve the paradox and learn how the world's biggest animals avoid cancer, we'll have a much better idea of how the disease works. We might even be able to use some of nature's techniques to improve how we treat cancer in humans. So far, scientists have made some important clues. An anti-cancer defense mechanism. Not long after Peto started pondering his paradox, two other cancer research UK-funded scientists, Dr. Lionel Crawford and Professor Sir David Lane, went fishing for molecules with a monkey virus. They hooked a tiny protein we now call P53. It wasn't clear straight away, but that was the first time anyone had found a protein our body uses to prevent cancer. P53 is a tumor suppressor. It stops damaged cells from copying themselves so they can be repaired. And if they can't, it causes them to die, meaning DNA damage can't build up into cancer. Lane nicknamed it the guardian of the genome. You can see P53 at work if you've ever been sunburnt. Sunburned skin peels off because P53 switches on a self-destruct pathway inside sun-damaged cells, helping to prevent us from skin cancer, at least most of the time. Very, very interesting article, and I'm going to continue on with it, but there's lots and lots to talk about. This is just a festival of wildlife. How fabulous. So it seems we've got a lot to learn from elephants, scientifically speaking, around cancer in particular, because they've even got extra anti-cancer genes. Because problems with P53 are linked to most adult cancers. The gene responsible for making P53 is called TP53. Humans have one copy of it, containing two versions in every cell. It's important for protecting us from cancer that people born with only one functioning version of TP53, a condition called Li-Fraumeni syndrome, have been reported to have a lifetime cancer risk of more than 70%. Every cell in an African elephant contains 20 copies or 40 versions of TP53. They don't all work the same way, but with 38 extra versions of the gene on the job, elephant cells are much more vigilant about DNA damage. They will self-destruct to prevent mutations that our cells won't even respond to. It's not that all or even most of these changes would lead to cancer. With so many chances for things to go wrong, though, elephant cells shoot first and ask questions later. Elephant TP53 seems to act that way wherever you put it. Lab studies have shown that it presses the self-destruct button when introduced to human cancer cells too. In a study last year by a team of researchers from across Europe, including the chairman of Save the Elephants, Professor Fritz Vollrath, explained how there are important differences between each copy of elephant TP53. They all have their own ways of interacting with other proteins in the cell, making it harder for cancers to disable enough of them to escape detection. By comparing exactly how these different copies of TP53 work, the researchers hope to learn more about how our own bodies fight cancer. They've also suggested that supporting the TP53 in ourselves, mimicking elephants' different copies of the gene, could be.
Do you want to know more about the spotted cat of the festive season? Join Gabe and Cedric for a Cheetah Chase AMA this International Cheetah Day.
Good afternoon, everybody. My name is Cedric Dahl.
Ask our expert naturalists any cheetah-related questions and learn more about the quickest predator of the safari.
Yeah, it's gonna get it. Oh!
Watch it live and come along for the fun. WildEarth, it's in your nature.
But as they grow bigger, elephants manage to hotwire a second one. Now, when DNA in a cell is damaged, P53 is able to bring the zombie copy of LRF back to life. It gives elephant cells an extra trigger to self-destruct, a process known as apoptosis, or programmed cell death, another fail-safe for responding to damage that could turn into cancer. It's absolutely incredible. So it's not too long, and we'll be introducing the Africam waterholes as well. And I wonder how many elephants we're going to see across those locations. But we'll be introducing that soon, and so we'll have a chance to go across to the Africam waterholes as well.